Okay, I'm back and I look older. I'm going to be solving count primes on Leetcode. Given an integer n, return the number of prime numbers that are strictly less than the given n. Pretty straightforward. 10, if 10 is the parameter input, we get 4 because there's 4 prime numbers less than 10, and so on. I guess they don't have an example of like 1,000 or 100,000. That'd be interesting. First thing I'm going to do is create an array, name it ARR, set it to a blank array. Create a for loop. We're going to start at 2 rather than 0 because there's no point in counting, looking for primes for 1 and 0. We're going to say if the index is a prime number, we're going to push that into the array we just created. Array.push index. Now you're probably thinking, what the heck is this is prime? It's a helper function we're going to create right here. I just want to return array.length because this is it right here. The only thing we're missing is this is prime, just to check if this index is prime. And then this is where the coding just gets kind of beyond me. It becomes very confusing at this point. Let me demonstrate. Taking a number just like the main function does, but we're going to name it num. Do the for loop. Inside that for loop, there's a conditional. Initiate I equaling to 0. It's going to loop into the array length and the array index. So it'll loop into depending how many items are in the array, and that will be less than or equal to the square root of this num parameter right here. Very confusing, I know. Okay. Now this conditional right here will be checking if num modulo of the array index equals 0. So if the num has any remainder equal to 0, like it's being divided, and if it has any remainder, we return true. This is if it's not a prime number. This is the outcome if it is a prime number. So it runs through the first test. If it passes both of these tests, it's not a prime number. If it fails either one, it defaults to a prime number. Probably one of the harder problems I have solved. Let's see if it's solved. How about that? So this is a linear runtime complexity. Since we're doing a for loop and a helper function here that has a for loop in it, it is 2n runtime, but that obviously simplifies to just n. This can also be O of A plus B because it has 2 loops. Not positive, but regardless, it's a linear O of n runtime because the array, the number can be any size. So, and then the space-time is a constant O of 1 because this number doesn't need to get any bigger as the problem progresses. You guys take care now, okay?